Hello, welcome to another class in digital image processing. In this class, we will be starting a new unit, that is image morphology. So in this class, we will be discussing about morphological image processing. The word morphology, it comes from the branch of biology, which actually deals with the form and structure of animals and plants. So we will be doing a similar thing in image processing. So mathematically, morphology can be defined as a tool which extracts image components that are useful in the representation and description of the shape of the region. So to detect a specific region of our interest and to extract information about these components, we use the term uh, morphology in image processing. The basic language that we use here for mathematical morphology is the set theory, which all of you have already studied. So we basically use the two-dimensional integer space for representing a set. In this two-dimensional space, each element that we show will be the coordinate of a pixel in the image. And in our explanation here, we will be considering a binary image. So the coordinates xy will indicate whether at that particular position I have a black pixel or a white pixel. Now let us look at some basic concepts in set theory. This is already dealt in your mathematics courses. As you know, a set is usually specified by the contents of two braces. The elements of these sets are actually the coordinates of the pixels representing objects or other features of interest in an image. Now, for example, when we write an expression of this form, say C is equal to W such that W is equal to minus T for D belonging to T. Now, what this actually means is the set C that I am talking about will have all the elements W, where the W is formed by multiplying the elements of D by minus 1. So that means the coordinates of a particular image, which is written as a set D, will be multiplied by using this particular equation, and the coordinates will be multiplied by minus 1. So let us try to understand the set theory in detail. Now if every element of a set A is also an element of another set B, then you know A is said to be a subset of B. This is the symbol that we use. A is a subset of B. Union of two sets is a set of elements belonging to either A or B or both, given by this expression. Intersection of two sets is the set of elements belonging to both A and B, which is given by A intersection B. Two sets are said to be disjoint or mutually exclusive if they have no common elements. So A intersection B will be a null set. The complement of a set A is a set of elements that are not in A. So A complement is a set where W is such that it doesn't belong to the set A. The difference of two sets A and B denoted by A minus B is defined like this. So it's actually A intersection of the complement of B. So it has all the elements W such that W belongs to A, but W does not belong to B. That means you are subtracting the elements of B and writing the set. Now pictorially, by using Venn diagram, this is how we can show intersection, subset intersection. So this area is actually intersection of A and B, union the entire set of A and B, A minus B. So the blue area here indicates A minus B because you are subtracting this part of B from the set A. Now let us try to understand a few more terminologies, that is reflection and translation. So the reflection of a set B, which is designated as B tilde, is elements W such that W is equal to minus of B. That means all the elements of B are multiplied with minus 1. So since, as I already told you, this is a set of the coordinates, so the meaning of multiplying the coordinates with a negative sign means that if I take this as the reference axis, and to the right in this area, if the coordinate values are positive, for example, if this value is equal to say 2 comma 1, then reflection means this will become minus 2 and minus 1. So you can observe that this point is flipped here. So as you can see, if I take this as the first quadrant, you can observe here, because I am multiplying with minus 1, it is going to this point. Similarly, this point has come here, as you can observe. Similarly, the operation translation can be defined such that now we are translating by z, where z is equal to z1 comma z2. So you can observe here, translated version of B will have all the elements C such that C will be equal to B plus Z. That means the original coordinates, I am adding the shift or the translation parameters to get the new image or the new set. So you can observe here, suppose if this is the original set B, and if I just translate by Z1 comma Z2, this is what is happening. So the 0th the pixel or the pixel at 0 comma 0 has been shifted to pixel at z1 comma z2. Similarly, all the elements are moved here. So this is how we can perform reflection and translation on a given set.